All right, guys, welcome back to chapter 7. So, in previous chapters, we talked about securing the perimeter of our castle using like firewalls, right? Today, we're going to move inside of the walls themselves, and chapter 7 is all about endpoint security. These are the devices that we touch every day. Think of them like our laptops, our phones, and our servers. If an attacker passes our firewall, the endpoint is the first line and really the last line of defense. So we're going to talk about how to armor up these devices so they can defend themselves. So our mission objectives for today, first we're going to analyze why the perimeter isn't really a thing anymore. We're going to compare the old school traditional antivirus against modern standards like EDR and endpoint detection response. We're going to look at the flight data recorder, the concept of the EDR itself. We're also going to look at how do we cover critical components like application whitelisting and USB blocking. Finally, we'll discuss mobile defense and how to handle personal devices in the workplaces. Because people are going to bring their own cell phones, how do we handle those? So, look at this image. This is really the modern of, well, our modern IT work as of today. The castle walls are gone. In the old days, everyone sat in an office behind a corporate firewall. That was very easy to defend. Now, today, with remote work and the cloud, your users are going to be working from different places like coffee shops, airports, and their living room. This means the endpoints, our laptops and our phones, is now the new front line. We're going to have to be tough enough to defend itself because the corporate firewall isn't there to save it anymore. So before we go in deeper, let's define our terms for this chapter. What exactly is an endpoint? Well, it's basically any device that connects to the network where data is accessed. Okay. Now, this could be your workstations like laptops, desktops, or even VMs. These could also be servers. Now, these are high value targets like file servers, web servers, and databases. These could be mobile, like smartphones and tablets. And then let's not forget about IoT, like our printers, cameras, smart sensors, thermostats, because often these are going to be our weakest link. So, how are we going to defend it? Okay, we're going to have to go through a major evolution in defense technology, moving from simple signatures like we did with antivirus to looking at complex behavior analysis. So, let's walk through each stage of this evolution. Now, stage 1 is going to be our legacy antivirus. This is what we grew up with. Okay, it works like a wanted poster. The software has a list of all known bad files, and it checks every file against that list. The problem is the failure rate itself. Hackers are smart. The software has a list of known and, well, bad files, and so it's going to check everything against that. Now, a hacker might use what we call polymorphic malware. Now, this is going to change its code slightly so that every time it infects a new machine, it looks like a new file. Because the code changes, the signature doesn't match, and legacy antivirus is going to be completely useless against zero-day attacks, brand new viruses, because it has no legitimate signatures for them yet. Which brings us into stage 2, which is our next-gen antivirus. Now, with AI and machine learning, instead of looking for the exact match, it uses math to analyze the file's characteristics. It says like, well, the file looks 90% like ransomware, so I'm going to block it, even if it's never seen that file before. It uses things that we call heuristics, which analyzes the code logic before it even runs. Okay, now this is much better than our legacy antivirus, but it still is mostly focusing on analyzing files. So we need something that can look, well, more into the actions of a file and not the file itself. And that brings us into what we like to call EDR, which is endpoint detection and response. EDR moves beyond static files. It looks at behavior and history. The best analogy for an EDR is a flight data recorder for your computer. It doesn't just block things, it records everything that happens. So let's look how that works. EDR itself is going to record what we call telemetry. It logs every process, what ran, Every network connection, where did it go? And every file modification, what changed? Now here's why this matters. Hackers often use standard Windows tools like PowerShell to attack you. Now PowerShell itself isn't a virus. It's a tool. So legacy antivirus won't block it. But the EDR sees the sequence. It sees that it opens up Word, and then Word launched PowerShell, and then PowerShell tried to download a file. Well, that seems malicious. So the EDR sees the whole story, and then it can trigger what's called an automated response, which could either terminate the process or isolate the host directly. Now, the EDR superpowers is going to help us as analysts, okay? The first thing it can do is isolation. With one click, you can put a digital bubble around an infected laptop, and it can talk directly to the security server, but won't be able to infect the rest of the network. The second one would be the remote shell. You don't have to walk down to the user's desk. We can remote in via a command line to kill the processes and delete files. And then third, it's going to allow us to have that timeline. We're going to replay the attack second by second to find the root cause. How the heck did it get in the first place? Now, if the EDR is the present, the XDR, extended detection and response, is the future. EDR only sees the endpoint, and XDR connects to the data with the network firewall and even the cloud systems such as email. Now, the benefit here is going to be correlation. Instead of 3 separate alerts, the XDR can tell us one story. The email gateway saw a phishing link, then the endpoint saw a file download, and then the firewall saw data exfiltration. It helps us connect the dots. So, detection is great, but prevention is better. If we can prevent it, let's talk about some of those controls that we can use that, well, goes beyond what we like to call antivirus. Now, our strongest control is going to be application control. Historically, we used blacklisting. We allowed everything to run unless we know it was bad. And this fails today on many because there's so many bad apps today that are created daily. So how do we keep up with the blacklist? So the modern approach just switched it. We went to whitelisting. We block everything by default and only allow known good apps like Office, Chrome, and Teams. If you do this, ransomware literally can't run because it's not on the list. It's quite highly effective. The next one is going to be USB drives. We all know not to plug in a random USB drive found in the parking lot, but unfortunately, people still do it. They can carry malware or be used to steal gigabytes of data in seconds. The defense here is going to be device control. The policy should be block by default, disable USB storage for everyone. If someone has a need for it for their job, you can create an exception that allows a specific user to use a specific encrypted drive, like by serial number is what we normally use it by. So let's shift our gears a little bit and let's talk about the computers in our pockets. Let's talk about mobile defense. So to secure phones, companies will use a thing called MDM, which is mobile device management. This software allows IT to enforce security policies, forcing passcodes, requiring encrypted backups, and even have the ability to remotely wipe the device if it gets lost. Now, the challenge here is the BYOB, bring your own device. Now, employees hate MDM on their personal phones because, well, they're terrified that IT will wipe their baby's photos or read their texts. Basically, they don't want anything that will actually break privacy. So the solution to the BYOD problem is containerization. Now, this creates a separate of church and state on the phone, right? That's what we like to say. So if you look at the screenshot, you'll see that there's a personal profile with a work profile. Work data is inside the encrypted container managed by IT. Now we can wipe just that container, and personal data remains private and invisible to IT. We can't touch it. Now this satisfies both the security needs and user privacy. So this is something that I highly recommend for everybody. Now, if we move down to the hardware level, we can even protect the boot process itself. We currently use UEFI, which is the modern replacement for BIOS. And a very secure boot feature is the other one that we like to use because this is going to check the digital signature of our operating system before it loads. Basically says, hey, is this actually the legitimate operating system we thought we were booting to before it actually boots? Because this is going to prevent bootkits, malware that tries to load before Windows starts itself. If the OS isn't signed by the trusted entity like Microsoft, the computer simply will refuse to boot. So let's tie all this together with a quick war story. In this attack, an employee opened up a malicious PDF. It was a 0-day exploit, so traditional antivirus saw nothing. But the EDR agent saved the day. The EDR noticed that Microsoft Word was trying to launch PowerShell. That is suspicious behavior. It didn't care what the file was named, it cared what it did. It blocked the process immediately, and the outcome is, well, no encryption occurred. The analysts used the EDR timeline to track it back to a phishing email and prevented it from happening in the first place. So now it's your turn. We're going to plan an exercise based on a local scenario. You are an SOC analyst for LCCC right here in town. They're setting up a public computer lab. Now, these machines are used by everyone, high risk, low trust. You need to create a hardening checklist of 10 techniques to make these machines resilient. Think about what we discussed. Think about guest accounts, deep freeze software, whitelisting. What would you do to protect these machines? All right, to wrap up chapter 7, we talked about the shift where endpoints are now the new battleground because the perimeter has been dissolved. We talked a little bit about reducing our attack surface by doing app whitelisting and USB controls. We talked about using containerization on our mobile devices, for the balance of security and privacy for those things like the BYOD, bring your own device. And then we talked about making sure that we use Secure Boot and UEFI to help protect the foundation of the OS itself. Now, that's the end of chapter 7. If you have any questions on endpoint security, let me know. And in the next chapter, we'll talk about securing software. Keep up with these chapters, and I'll see you for chapter 8.